Okay, mathematicians, welcome back. We're ready for our locus of points 2, where we're talking about compound loci. So you have your sheet. Let's get to doing our star, star, squiggle, squiggle. Today we're talking about compound loci, which just means that you have more than one situation going on at a time. So you solve a compound locus of points the same way as a single one. Think of it as a system of equations. Now, if you remember, we just finished doing systems of equations. And the solution to a system of equations is simply where the two systems intersect, the points in common, points of intersection. Except for this time, we are specifically looking at where the loci intersect. So, you know you have a compound system of loci. When reading the problem, you look for the word and or. That means those two things are supposed to act at the same time. The phrase to the left and to the right of those words are the two conditions that must be met. And again, here it says that the answer is where the two loci intersect. So if you are specific and you can tell me an exact ordered pair, or if you just have to put an X on the spot, sometimes they'll tell you to label it with an X, whatever the case may be. But in general, we just handle it the same way that we do the regular individual locus of points. So let's do the first practice problem here. It says Elena, well, we have a typo, but that's okay. She's planting a garden. Part of the boundary is a pair of large shrubs that are 50 feet apart. So we have to start off with our given is a pair of large shrubs that are 50 feet apart. So still we need to draw our picture. So we're going to put here, this is going to be shrub A, and we'll call this one shrub B. And we know that they are 50 feet apart. So we know that that total distance is 50 feet. And so part A says, if she wants to build fountains that are 25 feet from the two shrubs, they are asking us how many fountains must she build. So if they are 50 feet apart, the midpoint there is going to be our 25 feet. And so in general, we're talking about what is the locus of points about a point that is 25 feet away. And if you remember from the locus of points, that would give us a circle, which would have a radius of 25. And we have to do the same thing about what is the locus of point of shrub B. And that too would be a circle with a radius of 25. And so we're looking here to see where or how many places do our loci intercept. And I'm going to mark it with an X here. There would be one spot, so the answer to the question would be that she would need to build one fountain. Okay, scrolling down, let's look at, whoops, going the wrong way there, come on. Looking at part B, we still start off with our two shrubs that are also 50 feet apart. So we have shrub A, and we have shrub B, and the total distance again is 50 feet. And so this says now we need to figure out how many fountains she builds if they need to be 30 feet from the two shrubs. So now our conditions have changed a little bit. If I know the total distance is 50, I can divide this up by tens, 10, 20, 30, 40, 50 about. And so if I know the first one I'm going to have a radius of 30 feet, 10, 20, 30. So this is going to be my locus of points for any spot that would be 30 feet from shrub A. And similarly, I need to go 30 feet from shrub B, 10, 20, 30. So this is going to be my locus of points that are 30 feet from shrub B. So, of course, you know, if you had your compass, you might use a compass. And so here, I'm looking for the points of intersection of my two loci. I have one there, and I have another option here. So in this instance, she would have to build two fountains. Two fountains with an S. Okay, so make sure you're answering the questions specific to what they ask. So let's go on to example number 2, sorry. This one says how many points are in the plane that are 3 units from line M and also 6 units from point A, which is on line M. So here's that word and. So we need to talk about what is the locus of points that is 3 units from line M, and we also have to talk about a locus of points that is 6 units from a point that is on line M. So we have a couple of different things going on here. First, we need to look at our line M. We're going to start with that, and we'll label it M. And so let's look at this left-hand side here, 3 units from line M. Well, what is the locus of points that is 3 units from a line? Well, that happens to be 2 parallel lines. So I'm going to dash those in. There's one. And we have another parallel line here. And we know that they are both, I didn't mean to do that, I meant this. There we go. They are both 3 units from line M. And yes, they would be parallel, so we should put a little parallel symbol on there. That's the first condition. And then the second condition says we need to find the locus of points that is 6 units from a point A, which is on line M. So let's give ourselves a point A, which is on line M. And now we need to ask, what is the locus of points about a point that would give us a circle, and it would have a radius of 6. So if we know this distance is 3, we're going to estimate that the double distance would be 6 here. This we're going to say is 6 units. And again, it would be a circle. So we would sketch in our circle. And because this is a compound loci, we need to talk about all the points of intersection that meet both qualifications. So here we're looking for the points of intersection of our locus of points. So there's that. And so we really end up with 4 points that satisfy both solution. And the question asks how many points, so we need to state that there are 4 points. Okay, we're going to box that in so we know that that's our final answer. Okay, so be as precise as you can. We don't know what those ordered pairs are. They're just 4 points where our locus intercept. We have one more example. We have example number 3, which says find the coordinates of any point in the plane equidistant from point 1, 3, 7, 3, 4, 0, and 4, 6. So we've got some plotting to do here to get started first. So let's plot our points. First we're going to have 1, 3. That's point A. Point B is 7, 3. So we go over 7, up 3. That is B. Point C is 4, 0. That's point C. And point D is 4, 6. Over 4 and up 6. And that gives us point D. Now, we could draw in our lines here just to kind of make a shape. Let's see how thick this line is now. Okay, so we want to have straight lines from there to there. I have one from here to here, one from here to here, and one from there to there. Okay, so we really have a quadrilateral there. And we need the locus of points that is equidistant from all of those points. And if you looked at them 2 at a time, we would know that if we looked at segment AD, the locus of points would be the perpendicular bisector. Okay, and if we looked at DB, it too would be the perpendicular bisector. Locus of points between 2 points is going to be the perpendicular bisector. So we have a couple of options here. Okay, options. One option, because we know it's going to be the perpendicular bisector, we could use the compass. And we could bisect each segment AD, DB, BC, and CA. We could bisect it and find the point of intersection. Or the second option would be to, if we found the midpoint of each section and then connected those midpoints and the point of, that would be equidistant between all of those. So let's do the midpoint. So if we found the midpoint of segment AD, we would need to find the midpoint of segment DB. We need to find the midpoint of segment BC. And we need to find the midpoint of segment CA. We need to find the midpoint of all the segments, then we're going to connect them, and the point that comes in common will be the point that is equidistant from all of those. Okay, so here we go. Midpoint of AD, and you know, for the midpoint formula, we sum the x's, divide by 2, sum the y's, divide by 2, and we're using the ordered pairs A and D, so we're going to have 1 plus 4 over 2, comma, 3 plus 6 over 2. And when we simplify that, we end up with 5 halves, comma, 9 halves. So if we were to plot those, 5 halves is 2.5, so we're going to go over 2.5, and 9 halves is 4.5, so over 2.5, up 4.5, we're going to have a midpoint at about right there. We need to do the same thing for using the ordered pairs D and B. So we would have 7 plus 4 over 2, comma, 3 plus 6 over 2. And simplifying that, 7 plus 4, we would get 11 over 2, comma, 9 over 2. So 11 over 2 is 5.5, which would be here, and up 4.5. So 5.5, 4.5, we would have the midpoint about there. For segment BC, we would have 7 plus 4 over 2, comma, 3 plus 0 over 2, whoops, plus 0 over 2, and that would simplify to 11 over 2, comma, 3 over 2. 11 over 2 is 5.5, so we go over 5.5, up 1.5, that would be there. And the last midpoint would be for CA, which means we would have 1 plus 4 over 2, comma, 3 plus 0 over 2. And simplifying again, we would have 5 halves, comma, 3 halves. So 5 halves is 2.5, so over 2.5, up 1.5, that would give us that midpoint. And so now we need to connect those midpoints. And let's see what we get, what the ordered pair is going to be. So if I went from this midpoint to this midpoint, about that, and I went from this one to this one, looking at where they intersect, I would see that the point equidistant between all of those is this green ordered pair, and that answer would be 4, 3. 4, 3 would be the point or the coordinates of any point in the plane that is equidistant from all of those spots. Now again, you could use your compass and bisect those segments. You probably could also use your compass and get the locus of points, which would be a circle, and wherever all 4 of those circles intersected. So you had quite a few options here. So the rule of thumb for compound locus is just you treat them individually. You solve the locus of points just the way you normally do, except for you have to do more than once and then tell me where the locus of points intersect. Okay, that's the end of compound points, and we're done. See you tomorrow in class. Bye.